All right, I want to show you a different style of clamp that you may or may not be familiar with. I have not used this in the past. It's only been in about the last year or so that I've used these clamps, and I used quite a few of them at a job I was asked to come over and help with. But these are called Behringer clamps, and that's the paper there. I got that. This is for 3-inch schedule 40 pipe, and this one here is for 4-inch schedule 40 pipe. And as you can see, these are not perfectly round. They're kind of elliptical here on both of them. This base is designed to be welded onto something. So you will have that welded down, and then this whole bottom comes off. All this comes apart. It just kind of sets right down on there, and then as you put this over your pipe and begin to clamp it, it bites down on all of these surfaces all the way around and does so far for me, it's done a very fantastic job on limiting vibration, pulsation. These are called vibration isolators. I've seen these more often with hydraulic lines than I have in pipe. Like I said, I haven't seen anybody else around here using them, but I've had a couple jobs where I've needed them. I will show you when I get over to another job site how I installed them over there. But I get these from Grainger, so I order them through Imperial Supplies. They're not that expensive. Behringer doesn't offer that much in guidance as far as everything, as far as how many you need and where you need them. But I'll show you when I get over there, but I put them in fairly close, and they worked well for me. So just wanted to show you this. Late spring, early summer of this year, I was asked to go over to a place that was having trouble with 2 of their truck loading pumps. Each pump was a Corken Z4500. And when I was over there, they were explaining what was happening. I was looking at everything, and it was really clear that their problem was that their pumps were cavitating very, very badly. And then the next thing was to figure out why they were cavitating. Well, what it amounted to was a supply issue. When I go over, I'll go over there and I'll shoot a short video showing you how I installed the Behringer clamps over there. And I'll show you where the problem was and how we fixed it. But I ran into something very interesting here. I ended up rebuilding both pumps, did a complete rebuild, new vanes, new push pins, new cam liner. The rotors were salvageable. I had to clean them up. They had a fair amount of rust in them. And then I put in new mechanical seals on both pumps, and on one pump I had to put in a thrust bearing and a bearing race. So if you're familiar with Z4500 pumps, you know that there are 6 vanes and 5 push pins. This is what came out. 1, 2, 3, 4. Same thing over here. I had all 6 vanes and 1, 2, 3, 4. The 5th one in each one was just missing. You can tell by looking at these pins, they're only mildly mushroomed on the end, just mildly. They're not horrible bad. I had to push all of them out. They didn't want to naturally just drop out, but I had to kind of push them out. And then these 4 are a little bit more mushroomed than the others. These were a little bit more difficult to get out, but they all came out. Well, the real question is what happened to push pin number 5? And I was wondering, did the factory not install that push pin? So I thought, well, there's one way to find out. These, when these push pins are installed in the rotor, there's 2 of them, another set of 2, and then a single one. Well, it was the single one on each pump that was gone. It was missing. Well, when you look here on the bottom, you can see here's a pair where the push pins were hitting. So we know those 2 were there and they were hitting. Here's my other 2 set of push pins. They were hitting. And lo and behold, that single one was in that pump at one time because it ran in there long enough to make the indents. Well, it was gone. How that push pin made its way out, I do not know. I just know that it made its way out. And you can see there's some wear on here. And to give you an idea, here's a brand new one. Now you can see it's scored up, but it's not like it's missing an incredible amount of material. These vanes are very, very tough. Corken changed their composite. They had their supplier change the composite material sometime around 2014, 2015, and my place was one of the first ones to get the new compounds. But you know, so then we get over here, same thing. Put these together, and you see where the push pins were hitting here and hitting a lot lighter over here. They weren't hitting very consistently. And that's kind of nasty. That's a bad one. And then same thing, you can see where the push pins were hitting there. And you get over here and sure enough, right in the dead center, the push pin was pushing. So that means both of these pumps came from the factory with that 5th push pin. Well, it was missing. So essentially, this pump here, where was it? Yeah, there's my center one. So these 2 were missing their push pin, so they were really doing next to nothing. This one had its 2 push pins, but with that much of the vane missing, this was really not doing much at all. In reality, this pump was pumping and it was really only working off of 3 vanes, these 2 and then that one there. So no wonder it's had poor performance. And then on this one over here, once that push pin goes out, these things will kind of slop around in there, but they will not do their job. So in reality, this pump was pumping with only 4 vanes. And because I was redoing everything, that's why I decided I would just put in a new cam liner. And then I took the side plates and I reversed them. And everything else went back together, and it's running very smoothly right now. But just like I said, I don't know if you'll ever run into that again. The parts, I caught some of the push pin material in the strainer at the vapor eliminator. I never did find all the parts that came off of that vane. So the line has all been cleared. Line's been cleaned out all the way from the pumps to the eliminator. So wherever it went, you know, good riddance to that part. It's gone. I'll never catch it. But I just thought that was interesting, and I thought you guys might find this interesting as well. Thank you. All right, I'm out here where I had worked on these pumps, and I just wanted to show you my setup that I have for these Behringer clamps. As you can see, we got a fairly long little run here. We're about 17 feet. From about here to there is about 17 feet. And My welder and I came up with a plan on building support brackets, and so I wanted to come up with a way to build a support bracket to where my welder didn't have to be on site, so we didn't have to custom make every single support in here, because that raises the cost. And so I came up with this modular plan to where they have a top and a bottom, they'd be the same, and I could just use electrical strut bar in between and then bolt it all in place, hold it in there. Well, here's a 3-inch Behringer clamp, and there's the welded on base. And then you can see here there's a gap, and there the other one's a gap, and that's a pretty common thing, that they won't fit flush, but they do fit circumferentially all the way around that pipe, and that's what holds it in place and gives it its rigidity and calmness. And then you can see down here I just went ahead and put 8 lags down inside here, and because these two I wanted to kind of keep them all tied together, so we just put this in here, and was able to install these by myself, so it wasn't that bad. Then we got the same thing over here. I want to show something here. I wanted to carry the weight of this 3-inch flange bypass valve, so we made this bracket here, and then it's just, you can see it kind of is in there, and it carries the weight of this. And then we put this all together and got it all bolted and clamped into place. I got another Behringer clamp here going in the bypass line. This is the pump that cavitated the worst, and as you can, let me get back here far enough. When I first started in here, the pump, the flange inlet on the pump, was taller than the flange on the strainer. So from here, from this height to this height, this pump sat up 1 5/8 inches. So unless this thing was running a lot and you had the right temperature and you had the right everything, this pump always wanted to cavitate, because it always wanted to trap propane vapor up in here as it went uphill. Well, without tearing everything apart and completely redesigning the piping, I took off the pump, the gear drive, and the motor, moved them all off to a side. I pulled the base, took it to my friend Mike Husband up at Fab and Weld up in Berrien Springs, Michigan, and we had him cut that base down 1 5/8 inches. And then when I put it all back together, that got me level. Well, to get back up here to the same height as my piping, we raised this piece up right here 1 5/8 inches. So that gave that, so I was able to maintain my height across through here and get all this around. So that was the only solution I could come up with. So far it's been working really well. If you are ever running into a situation where your pump is having a problem cavitating, or is having a problem, depending, if you've got, let's say, like a Corken C10 or C12 or something like that, and it runs a long time and it just doesn't seem like it's getting a prime, you want to make sure that you've got a good flow, a good level flow, or a flow that's running down toward your pump, because these types of pumps they don't create suction. You have to have a different type of pump to be able to do that, because these pumps aren't designed to pull product up. They're designed to be fed. And so if they struggle getting fed, then they struggle performing. So just something to keep in mind.